And then, as always, r is the radius, which is half the distance from the center to the edge. Diameter would be all the way across, and so on. First example is the volume of a sphere with a radius of 8.8 inches to the nearest tenth of a cubic inch. So we want the volume equals 4 pi r cubed all over 3. 4 times pi is just a number times r. The radius it gave us was 8.8 cubed all over 3. Please don't multiply 8.8 by 3, right? So we have 4 times pi times 8.8 cubed, and then we're going to divide that all by 3, and we get 2,854, and then if I'm rounding properly, 0.5. So 2854 plus 5. And then this was in inches, so it'll be cubic inches since it's a volume. Okay, and that's like the very basic. Here's a sphere, here's its radius, what's its volume. But then we can get other ones. So what is the volume of not a sphere, but a hemisphere, which means half, right? It's like a semicircle with not a radius, but a diameter of 3.7. So if we have a diameter of 3.7, doesn't our volume require a radius? How do I find the radius if I have a diameter? What do I do to my diameter to find my radius?
Divide it by 2?
Yeah, cut it in half, right? The radius is half the diameter. Yep. So what would that be? I think, right? I don't know if my brain's working at top speed right now. Do I trust myself? I do. Okay. 1.85. Yep. Okay, so we have a radius. So we do 4 pi, and then our radius is 1.85 cubed divided by 3. So 4 times pi times 1.85. 85 cubed divided all by 3. 26.5. Oh, but hey, wait. It's a hemisphere, right? That's the volume of a whole sphere. So to find the volume of a hemisphere, I should cut that in half as well. 13.3. And this is in cubic meters. All right. So really, I took all this, and then I divided this by 2 again to get the volume of the hemisphere, right? So that was the volume of a sphere. A hemisphere is going to be half of that. So again, just be careful with everything that they give you. Last type of problem you'll run into is when they give you the volume, right? So you still have all those things. You could be given a sphere, a hemisphere, a radius, a diameter, any combination of those, and then they could give you a volume instead. So what is the diameter? So now we're looking for the diameter of a hemisphere with a volume of 5078. Well, okay. So we know that the volume of a whole sphere is 4 pi r cubed over 3. And then, how do I want to go about this? The volume of a hemisphere is half of that, right? So we kind of have two ways to go about it. We could double this volume to get the volume of the entire sphere, right? If this is a hemisphere and this is, let's do it that way. Let's do it that way. So we're given the volume of a hemisphere, but we know the volume for a whole sphere. So if this hemisphere was a whole sphere, wouldn't it be double? So just times it by 2. 10,156. All right. So it gave us the volume for a hemisphere. We have the volume for a whole sphere, so double it to make it a whole sphere. Now we know the volume is 10,156 equals 4 pi r cubed over 3. Now we have to solve for r. Okay? Just like solving for any other variable. First, I'm probably going to multiply the 3 over. And so the 3's cancel. So we have 3 times 10,156. We get 30,468. Now I'm left with 4 pi r cubed. Now I want r by itself. And I have times 4 pi in the way, so to get rid of multiplication by 4 pi, I'm going to divide by 4 pi. Then I'm going to go back here and divide by 4 pi. 24.566. Oh, r is still not by itself. What's in the way? How do you undo a cube? If it was square, how do you undo a square? So don't square root it, but cube root it. So if we take the cube root, the cube root of r cubed is just going to be r. I'm going to write it on this side. So on our calculator, we should do, where is the button where we can choose? Hold on. Let me look on this one. You know what? I'm just going to teach you guys a trick. To cube root, I could look it up in a second how to actually cube root, but so I'm going to use my answer, which is just the number I got for the radius because I need to cube root it. If you want to cube root something, you can put it to the 1 divided by 3 to the power of 1/3 is the same thing. And why is that? Maybe I'll do a little, if we had r cubed, and you guys should have gone over properties of exponents in integrated math 1. If you put that to the 1/3, exponents to exponents, you multiply 3 times 1/3 is 3/3. 3 divided by 3 is 1, something to the 1 power is just itself. So we essentially took the cube root, right, because we got rid of the cube. So we can just put our answer to the 1/3, and that's like cube rooting it. 13.4 if I'm rounding. Oh, and then being extra careful, it didn't ask for the radius, it asked for the diameter. So I need to double this, right, to get the diameter. So I should get 26.8. And then we were in, what, meters? Yeah. And then this is just in meters because it just wants the diameter, not the volume. So there we go. And that's the 3 examples I have for you. So try and get those 3 done on Delta Math so that you have none for the weekend. Whatever you don't finish is going to be due over the weekend. Let me see if I have anyone done with it. If you're an online one and you're done with it, you will be welcome to leave. Let's see. We got a couple that are close. Isabella's done. I think that's 3rd hour, isn't she? Yeah. So. Let me see if I can find the cube root on the TI-84. I found the cube root button in case anyone wants to know. So on your TI-84, if you're using that, the cube root, if you hit this math button on the left side, right under the green button, if you hit math, you'll see it's this 4th one right here, number 4. It'll let me go. Go. That's the cube root. And then you just put whatever you need into there.